Okay, today's lesson, we're going to talk about how to do the inverse Laplace transform. And in particular, we'll talk about how to do it by hand and also by MATLAB. Now, just as a review, big picture of what we were doing is that we have an input equation, might be a voltage going into a circuit, and we want to find the output. So maybe it's an input voltage going into a circuit, and we want to find the output voltage. Now, in order to do this directly, if it's a complicated input, we have to use differential equations. Instead, because differential equations are hard, we're going to use Laplace transforms. In the past two lessons, we've worked on using Laplace transforms to change our Vn as a time waveform into our Vn, capital Vn now as a frequency waveform. We haven't yet talked about how to modify our circuit and take a Laplace transform of our circuit. That's going to be in our next lesson. But it turns out to be pretty easy to create an equation in S that perfectly explains what our circuit does. We're going to call that H of S. So now in the frequency domain, it's as if we're placing our input Vn into H of S, and what we get out is just the product of our input times the Laplace transform of our circuit. So realize again that we are multiplying here in the frequency domain, which is something that only the frequency domain lets us do. You can't multiply the input in the time domain by some sort of equation that represents what the circuit does in the time domain to get the output, but you can in the frequency domain, at the cost of having to do an inverse Laplace transform to go from your V out of S into your V out of T. So that is the section that we're going to cover today, how to do that inverse Laplace transform. And I want to motivate that with a simple example of why this is important. There's been a lot of interest lately in how we can transfer energy remotely, say set a satellite up in space, big solar panels, and then take the energy from the sun that it receives and wirelessly transmit it back to the ground. Nikola Tesla, 100 years ago, worked on this problem and came up with this system. If you excite it with an unusual looking input, a quickly decaying exponential waveform, this is a capacitor and this is an inductor, it can create very large pulses of electricity on the output that can be sent wirelessly through an air gap. But to analyze how this works, with our V in and finding our V out, we need Laplace transforms, and in particular, now you know how to find the Laplace transform of this. It's 1 over S plus 10. But you don't know how, after we find V out of S, to go to our output waveform. So that's this class.